which will require to prove the chain rule. Let S subset of Rn be a non-empty open subset. If F from S to R be a scalar field and F is differentiable at E belongs to S, let G of T that is equal to F of E plus TV for V belongs to Rn, correct, and T belongs to R, then G is differentiable at 0 and G dash of 0 that is equal to df of A at V, correct. Yeah. Whether it is disconnected. So let us try to see what the theorem tells you. Uh, there is a function which is differentiable at A, that is scalar valued function, and I am making that function to another function g, that is g of t. G is function in one variable, correct. This is function in several variable. I want to relate this with function with one variable. So g dash of t will give me the derivative, that is df of e at v, correct. So let us see. This will help us to give the chain rule. So let us quickly write the proof of this. For epsilon be given, note that what is g of 0? G of 0 will be f of a, correct. So the e belongs to s and s is open. What do you mean by open state? Then there exists r positive such that bar is contained in s. Okay. Yeah. Nee. OMG. Yeah, just forget about this part. This is so let us start. Let V belongs to Rn be non-zero any non-zero vector be such that epsilon equal to R upon norm V. Okay, so for mod t less than epsilon, consider this. Consider norm of E plus TV minus E. So that is equal to, what is E plus TV minus E? That is norm of TV, that is equal to mod t norm V. Since t is a real number for us, so that is less than equal to epsilon norm V, correct. And what is this? Epsilon का value क्या use किया? R upon norm V. So this will be less than R upon norm V into norm V, that is equal to R. So what do you mean by that? E plus TV also belongs to this. E plus TV also belongs to BAR. See, E plus TB का subtraction with respect to Ilia, and this is less than R. So E plus B belongs to R, that is subset of R. So now consider your function. Consider G of T that is equal to f of E plus TB. Now I know that E plus TB is my interior point of this open ball, correct. So what we will have to prove? We will have to prove differentiability of G dash, that is this is function of one variable, correct. Will prove this function of one variable is differentiable at 0. Okay, so how will you prove differentiability? What we are given that f is differentiable, so let us use that. Given f is differentiable at a, so with the total derivative, differential means it will have a total derivative. Total derivative say df of a equal to t, correct? So let us write the definition. For epsilon positive, there exists delta 1 positive such that norm of h less than delta 1, that implies mod of f of e plus h minus f of e minus t of f. What is the definition? करेक्ट, जो भी था वही लिख रहा हूँ. Norm of h that is less than epsilon upon norm v. Correct. Now let h equal to tv, and what is norm h? That is less than delta 1. That implies norm tv that is less than delta 1. What do you mean by that? This is mod t, norm v that is less than delta 1. That means what? Mod t is less than delta 1 upon norm v. Correct? Okay. We'll be using this somewhere. So, yeah. Here I'm having h की जगह पे आएगा norm tv. So, what I'll do, this is, let us choose delta. Choose this delta upon, see, delta 1 upon norm v. I'll choose this as a new delta. Choose delta equal to delta 1 upon norm v. Let us see what will happen now if you go on solving this. So that means your norm t, sorry, mod t, that will be less than, now I am having delta, and that will be equal to g of t minus g of 0 upon, it is c. Okay, yeah, I want to consider this. I'm considering part minus, that is जो भी मुझे proof करना था, df of a of b. Correct. So what do you mean by that? That is equal to, this is g of t minus g of 0 minus this will be t times df of a v upon t. Correct. Something like this. So what is that? G of t is f of e plus tv minus f of a minus, what is this? This is t times t of v. Since it is linear transformation, I can take inside, and this is t. So what I do now is mod t. Correct. What I do now, I multiply and divide by norm v both the side. Norm v multiply by norm v. Correct. So what I will be having, look at this. I can combine these two people. I can combine this. So I'll be having f of e plus tv minus f of a minus t of tv upon norm of tv, and that is multiplied by norm v. And you know that what is this? This is already less than epsilon upon norm v, correct? That is actually less than epsilon upon norm v. So if I write at this place, this is less than epsilon upon norm v multiplied by norm v, that is less than epsilon. Correct. What did you prove? This function is differentiable and derivative is this. That means this proves that g is differentiable at 0 and g dash of 0 is df of a at b. Means proved. That was simple. Correct? Yeah, I'll just quickly repeat. Let S, that is subset of Rn, be a non-empty open subset of Rn if f from S to R be a scalar field and f is differentiable at E belongs to S. Correct? So this f is this is vector valued function. It is taking no, it is scalar valued function, but it is in n variable. That is its input in n variable. Correct? Now I want to I want to make this, I want to relate this f with another function that is g, and g of t is equal to f of e plus tb. G of t is a real valued function. It is taking t. Oh, I don't know actually. There is some internet issue. I'm sorry for that. Now, why did I prove that theorem? Just I wanted to relate with this chain rule for scalar field. Chain rule for scalar field. Okay, so let me write the statement. Let S be a non-empty open subset of Rn if f from S to R be a scalar field. Let I, that is in R, be an interval, and let alpha from I to S be a function. Let g from I to R be defined by g of t is equal to, say, f composite alpha of t. Okay, that is f of alpha of t for t belongs to I. Okay, let t belongs to I be such that alpha dash of t exists, and let f be differentiable at alpha of t. Then g is differentiable at t, and g dash of t is given by delta f of e multiplied by alpha dash of t. This is the definition where what is e? Where e is your alpha of t. Correct? So this is your chain rule. If you want to differentiate this f of alpha t, so what will be that? That will be delta f of a dot alpha dash of t. Correct? Since here your f is the function taking from n variable and going to r, so it will be delta f of a into alpha dash of t. If you remember, we most of the time we use this, even will be using it in the solving line integral, even in complex analysis also will be using this chain rule criteria. Okay, let us try to prove this quickly. So what we are given with, we are given g f is differential. You want to prove g is differential. We are defining a new function g, which is this, and we want to relate with that. What about g dash of t? Correct? Let us write the proof. Okay, so we are starting with let a equal to alpha of t, that is given to s, and that belongs to s, where t is the point of I at which alpha dash of t exists, and s is open set. Implies what? We can take h small enough so that अल्फा ऑफ टी प्लस एच बिलोंग्स टू एस, करेक्ट, जैसे अब उधर किया था पिछली प्रूफ में. एंड let y equal to alpha of t plus h minus alpha of t. That implies alpha of t plus h is equal to alpha of t plus y, that is e plus y, correct. So as h tending to 0, y tends to 0. Consider g of t plus h minus g of t. What is this? This is f of alpha of t plus h minus f of alpha t, correct. And what is this? You multiply alpha, it will be alpha h, and alpha is y. So let us see in the next. This will be f of this will be e plus y minus f of e, correct, because e is alpha t. Yeah, now f is differentiable. Let us use f is differentiable at e implies what? There exists a linear transformation t from Rn to R such that limit y tending to 0 mod of f of e plus y minus f of y minus t of y upon norm y, that is equal to 0. This limit is 0, correct. Let us use the same technique जो हम लोग ने पहले यूज़ किया था, that let e of ey that is equal to f of e plus y minus f of y minus t of y upon norm y, correct. So what do you observe? That is, as y tends to 0, e of ey tends to 0, correct. So from here can I get the value of f of a plus y minus f of a, that is f of e plus y minus f of e, sorry, f of y. What will be that? Just multiply. This will be e of sorry, it will be norm t, no? That is t of y plus norm y into e of ey, correct. Where you know that e of ey goes to 0 as y tending to 0. So let us see what is derivative. G dash of t. What is the definition? Limit h tending to 0. It is g of t plus h minus principal, first principal, g of t upon h, correct. This is equal to limit h tending to 0 implies y tending to 0, and this will be f of e plus y minus f of e upon h, correct. Oh sorry, this is h. In later case this will be y. Let us actually substitute h equal to, then it will be easy. So let us put the value. Limit, what is f of a plus y minus f of a? This is t of y plus norm y e of ey, correct. And that is what? This is divided by h. Limit h tending to 0. That is equal to limit h tending to 0. This will be t of y upon h plus limit y tending to 0 norm y e of ey upon h, correct. So what is that? This is gone, as you know this guy goes to 0, correct. And here you will be having limit y tending to 0. This is ty upon h. And what is t of y? This is limit y tending to 0 delta f of e into y upon h, correct. So what will you write? What is your e? Let us put the value of e now. So this is limit y tending to 0 delta f of a. This is alpha of t plus h minus alpha of t, and that is divided by h. So this will be delta f of a. I'm taking outside. This is limit. This is your y tending to 0 alpha of t plus h minus alpha of t upon h. Correct? What is that? Sorry, this is h, limit h tending to 0. Why putting y? This was limit h, na? H tending to 0. Here also limit. This is h tending to 0. This is h tending to 0. That is delta f of e multiplied by what is this? Alpha dash of t. Alpha dash of t. Correct? And what is your e? That is delta f of alpha of t into alpha dash of t. So what did you prove? You prove this. That is derivative of your f composite alpha of t derivative. I'll write like this. Derivative that is equal to delta f of alpha t into alpha dash of t. Hence proved. Correct? I'll quickly revise the proof. This was the statement, that is g of t equal to f composite alpha of t, that is f of alpha t. I want to find the derivative of this, that is g dash of t equal to delta f of a alpha dash of t. Correct? So see here also your g of t is in one variable where t belongs to r. So I am relating g with respect to a function which is having n variable. Started with let a equal to alpha of t. So and then we consider this y equal to alpha of t plus h minus alpha t. So what is alpha of t plus h? That will go there, and as h tending to 0, y tending to 0. So either you put h 0, y 0, doesn't matter in our. Consider this g of t plus h minus g of t, that is this will be f of alpha t plus alpha h. So alpha h I can put at y, so that is f of e plus y minus f of a. So since f is differential, let us write the definition, and ये part को हम लोग e of e y लेंगे, and this cross multiply, take f of e plus y minus f of a, will be having this. Now let us find g dash of t. Since it is in one variable, you can use first principle. So apply first principle and you get this limit is tending to 0. So look at this part. This is your alpha dash of t, and hence proved. Correct? Yeah.